Hello and welcome back to the Scotti-BYTE channel, and this is Scott. So today we want to learn about how to secure access to an SSH session and make it available from the public internet. This may sound scary, but it's possible to make an SSH terminal session more secure and allow access from the public internet. We will learn how to change an Ubuntu server instance to ask for two-factor authentication, otherwise known as 2FA, during logon, and also ask for 2FA for use of the sudo command. We will learn how to install web terminal access with wetty, listed at the GitHub location here, and we will configure wetty with SSL using Nginx Proxy Manager. So here we are at the terminal prompt again, and if we do a lexc list on my lexd host, you'll see that I have a couple of other instances running. One of them is the Zork instance that we created in the last video. So today, I want to go ahead and create a new lexd instance. This could be a virtual machine, it could be a standalone machine, but it's based upon an Ubuntu 2204 instance of Ubuntu server. This can also be done with an Ubuntu 2004 instance, and I'll mention what that difference will be. If you've been watching my series of videos about lexd instances, you know now that we've created our instance, we can say lexc exec wetty bash, and it will enter the bash shell. Now with the new server instance, a virtual machine or a lexd instance, we want to do a sudo apt update and a sudo apt upgrade to make sure that the instance is completely up to date. With that out of the way, I'm going to do a sudo apt install net-tools. And a sudo add user Scott. Give Scott a password. And a sudo usermod -a g sudo Scott, adding Scott to the sudo group. Now we're going to add Google Authenticator with the sudo apt install livepan Google Authenticator command. So now I'm going to SU over to the Scott account because that's the account that we want to set two-factor authentication for. And I'm going to run Google-Authenticator. It says, do you want to enable authentication for time-based tokens? And the answer to that would be yes. We get a QR code which can be scanned by the Google Authenticator app on a phone, but we're not going to do that since I have a self-hosted instance of Bitwarden and I have a Bitwarden premium account. I'm going to go ahead and create a new Bitwarden entry. So I'm going to call this Bitwarden entry wetty. I'm going to have the username of Scott, and I'm going to put in my password. And then I'm going to grab this secret key down here, make a copy of it, and I'm going to paste it up here in the Authenticator key field. And finally, save it. So when I click on wetty, it comes up and it gives me an authentication key code that is good for 30 seconds. You can see here where it turns red, it means it's getting ready to expire and a new code will be issued. So now that I have the new code, I can click on copy verification code. I can come down here and paste it and paste it again, and it took it that time, and say yes, I really want to replace the one that's out there. And do you want to prevent man in the middle attacks? Yes, I would. Do you want to provide a ability to enter the code on either side of the time when it's issued, and it makes it a little easier to enter that way? I say yes. Do you want to eliminate time rate limiting, which basically means that it's hardened against attackers doing brute force attacks? So in order to turn on our two-factor authentication and enable it, we're going to have to edit a few files. The first file that we're going to edit is /etc/pam.d common-off. So I'm providing my sudo password. I log into this file, and I want to go all the way to the bottom of the file. And there are 2 lines that you want to add to this, which will be in the show notes. The 2 lines are as follows. And I provide an extra carriage return at the end of the last one. I'm going to do a Control-X, save the buffer. The next file that we want to edit is the sshd config file, and that's the file that is used to initialize the SSH server. We go into this file, and I want to go search for challenge CHALLENGE, and you can see that there's a password challenge. If you're running Ubuntu 2004, this field is actually called challenge response authentication, and it could be set to yes. If you're running Ubuntu 2204 server, the name of this field has been changed to KBD interactive authentication, and you also set it to yes. Once you've done that, go ahead and save and exit the file. And the next thing that we want to do is restart the SSH service with a sudo systemctl restart sshd.service. So one of the things that's very important about two-factor authentication is that your clock is in sync all the time. So another thing that we want to do is we want to do a sudo timectl, time-date-ctl set-ntp equal to yes, which is setting the network time protocol to sync from the time. And if you don't know what your time zone is, you can always do a sudo time-date-ctl list time zones. But in my particular case, if I can get this correct, I'm just going to set mine to America/Chicago, which is where my home location is. Now that the configuration of two-factor authentication has been completed, I'm going to log off of my wetty account, and I'm going to log off of root over here on wetty. And now I'm back to my LXD host. I'm going to do a LXD list, and you can see that the wetty LXD instance is running at 192.168.80.129. I'm going to log off of my LXD host, and I'm back at my desktop machine. On my desktop machine, I'm going to do an SSH over to 192.168.80.129. I'm going to provide my password. It's going to ask for a verification code. If I go up to my Bitwarden and copy that verification code and come down and paste it, it will log me in. Likewise, if I do a sudo su to try to grant myself sudo privilege, it will ask for a sudo password, and then it also asks for the verification code. I see that the verification code is getting ready to expire, so I make a copy of the new one as it comes up, and I do another paste, and I've been granted sudo privilege. So both the sudo command and the initial login prompt for not only the password, but for the two-factor authentication key. So now the next steps involve installing wetty, which is the web-based SSH terminal that we want to use with our system. So the first thing we want to do is a apt install git. And usually that's installed with your server instance, so you don't really have to worry about that. The next step is going to be a sudo apt install curl, build essential, and Python 3. So we'll go ahead and say yes and allow that to complete. We also have a second list of dependencies that you see here, and again, those are going to be in the show notes as well. The wetty program requires Node version 14 and above, so in order to do that, we're going to issue this curl command to add it to the repository on our system, and then we will do an install on Node.js. And finally, we do a node-v, and we can see that we are running Node version 14.19.3, which is above version 14. Now we want to install GNUPG2, which is privacy-based software. Next, we're going to install a repository for the Yarn package manager. And then we're going to install Yarn, or add it to the sources list actually. And now we install the Yarn package manager with the sudo apt update to update the repository, and then sudo apt install Yarn. Now we install wetty with the Yarn package manager with the command sudo yarn global add wetty. We're going to add the Etsy profile path to the path by exporting it. And then we perform the command source Etsy profile. And by this time, wetty is installed, and we can do a wetty -- help, and you can see the help for the wetty command. So in order to manually start up wetty to test it, we can do a wetty space -- host 0.0.0.0, which means started on this machine. And I'm using port 80. If you're using port 80 for something else, feel free to choose your own port number. So the program starts up, and the next step is to go to the web browser. To test wetty and see if it's working, I'm going to go to http://192.168.80.129/wetty, since that is the address of my wetty server. I hit enter. I get a login prompt. I'm going to go ahead and blow this up so you can see it a little bit better. I'm going to enter my username of Scott. I'm going to enter my password. And there's my two-factor authentication. And I'm going to copy from Bitwarden my verification code and paste it in here, and I am logged in. So I have a full-fledged terminal running in a web browser. I can clear screen. I can do list command, and everything works just fine. Returning to the command prompt, I'm going to go do a Control-C to break back out of this session, and we're going to go edit a file called /etsy/systemd/system/wetty.service. And if you watch my last video about the self-hosted game, then you notice that we created a service for it too. So we go ahead and we enter the nano editor, and in the nano editor I want to put my definition to start my wetty command whenever the system boots, or in this case when the LexD instance boots. So this is a pretty simple command. It just says the description is wetty and the type is simple. It just says exec start is run this thing in the Bash shell. I do a wetty space -- host 0.0.0.0 port 80, and I say the base is /, and that's just so I don't have to put a wetty at the end of the command, and that's basically all there is to creating that service. So I save the file. After I save the file, then I'm going to do a systemctl enable wetty, which makes it a system service in the system service table. And I'm going to start the service. And if you happen to go back and make any changes in that file, that service file that we just edited, then you can also do a sudo systemctl daemon reload, and it'll incorporate the changes you made into it. So now, since this all worked, let's go ahead and do a sudo reboot to see whether or not when the system comes back up, if wetty is a service that is started automatically. So now that the system's rebooted, I log back in, provided my password and my verification code. Here we are back at a prompt. Now, the next thing I'm going to do is I'm going to take a look and see if the system service wetty is running with the sudo systemctl status wetty. I have to provide my password because it's a sudo command, and I also have to provide the two-factor authentication code from my Bitwarden. And you can see that the wetty service is enabled and it's active and it's running. So meanwhile, back at the web browser, if I come back into the web browser page, since we told it we wanted the root to be at the top level, I can remove the wetty from the end of my command and just access 192.168.80.129, and I get a login. I type my username, I type my password, it asks for the verification code. I go over to either my Bitwarden or my Google Authenticator, and I paste in the verification code, and it logs me in. And this time we're accessing wetty from the web terminal as a service that has been started automatically when the LXD or virtual machine instance starts up. So assuming you're running Nginx Proxy Manager, if we go over to my Nginx Proxy Manager instance and we go list my proxy host and say add a proxy host, if we enter here 192.168.80.129 and we put our forward port in as 80 and we turn WebSockets on, common exploits on, go over to SSL, and assuming that we already have created a DNS entry at our DNS provider, then we can go ahead and create this. And oh yeah, by the way, you got to put in your domain name. So the domain name in my case that I added at my DNS provider was wetty.scotti.byte.com, and I click on add and click on save. And one final thing that I like to do is to scroll down and find my wetty instance that I created, edit it, go into SSL and click the force SSL to on, since you can't do that when you create the certificate originally. Now I click save. And now if I open a new web browser instance and I instead go to wetty.scotti.byte.com, you can see that it's bringing up my wetty instance, and it also has the lock to indicate that the connection is secure. Again, if I type my username Scott and I type my password and then I look for my verification code from my Bitwarden and I paste it in here, I am logged into the system. So now we have a system service that is reachable from the web to connect to a desktop SSH instance if required. So if you like the idea of using the entry with the domain name because it's convenient, but you don't necessarily want it to be accessible on the internet, then you can go over here to the access list option and you can create yourself an access list. In my particular case, I have an access list that I'll show you here, and it just points to my local network which is 172.16.0.0. And if I went back to my definition for my wetty instance, here at the bottom, whoops, didn't want to click on it. If I go in here to my wetty instance and I edit it, I can actually change it from being publicly accessible to my at home, and then only people inside of my network would be able to access it. But I really think we're providing the username, the password, SSL encryption, along with two-factor authentication is a very good way to secure your remote terminal access for instances where you may need to have that external access. So in summary, in this tutorial we learned how to enable Ubuntu two-factor authenticated login to secure both your SSH logins and also use of the sudo command. We installed wetty to create web-based access for SSH secured with SSL. And 2FA combined with wetty and an Nginx proxy manager entry can secure an SSH terminal over the web using SSL. Although you can use programs like Guacamole to web-base an SSH session, this provides a simpler capability that might be useful. Anyway, that's it for today. Please subscribe and like to the channel, and we'll see you next time.